All right, here's how to add or subtract the radicals, you guys, in simplified form. So we're gonna do evens first. So number 22, um, radical 10 cannot be simplified, so now we just gotta collect like terms, right? They all have the same radical, they all have the same root, and they all have the same radicand. So 4 plus 6 is 10, and then 10 minus 1, there is a 1 right there, is 9. So we're gonna get 9 rad 10 plus 2. All right. 24. Both of those have the same root, which is 2, and the same radicand. So 3 minus 6 is basically negative 3 radical y. Okay, number 26. These have the same root and same radicand, so we could just collect like terms, combine like terms, sorry. So 4 plus 6 is 10, minus 3 is 7, so we're gonna get 7 square root of x plus 2x. Okay, 28. Now, radical 15 cannot be simplified, so basically, we just combine like terms. So 12 plus 5 is 17. 17 minus 8 is 9. So 9 radical 15. Number 30. All right, so we got this, right? This, okay, I'm gonna make this thicker. Ooh, too big. Okay. This and that have the same root and radicand, right? So we're going to combine like terms right there. And this one has the same root and radicand as that one. And recall, there's a 1 right there, right? So our final answer is going to be, let's look at the green, okay? 3 plus 4, that is 7 square root of 5. And the negative 1 plus the 3, which is 2 radical x. And there we have it. Okay, off to 32. Okay, this is where we gotta simplify, right? So, square root of 8. Gotta find pairs, right? So 4, 2, 2, 2, there's a pair. So we know radical 8, that's gonna be 2, because since we found a pair of 2's, the pairs get to come on the outside and the leftover stays on the inside. Okay, so we know radical 8 is going to be 2 rad 2. Now we gotta do radical 12, right? 4 and 3, 2 and 2. Since it's a square root, gotta find pairs, so we have that. So that's gonna be 2 radical 3. Radical 3 is left over, right? So that looks to be our final answer. And let's just put both of these right here and this one right here. Radical 2 and radical 3, they have the same root, but they don't have the same radicand. So this is your guys' final answer. Can't simplify anymore. All right, 34. So radical 50. This is going to be 10 and 5, 2 and 5. So we found a pair of 5's, right? So remember, the pair gets to come on the outside, and the leftover 2 goes on the inside. By radical 2. Radical 72, we get 8 and 9, 3, 3, 4, 2, 2, 2. So we got a pair of 2's, and this side we got a pair of 3's. So the 2 comes out, and the 3 comes out, and the leftover is 2. So this, you guys, is going to be 6 radical 2. That's going to be the simplification of radical 72. And radical 8. So radical 8, we're going to get 4, 2, and 2, 2. Still looking for pairs, so we found a pair right there. So the pair of 2's get to come on the outside. Square root, and this is the leftover, so 2. So let's bring this all back together. So we got 5 radical 2. Okay, hold on. So I forgot to mention this radical 50 had that 4, right? It had the 4, so that means when we took out the 5 on the outside, this should have been multiplied by 4, which really should have been 20 radical 2. So let me erase all this. I'll just keep it so you guys could see. So essentially, for radical 50, that we solved for 20 rad 2. Negative rad 72, we got that to be negative 6 rad 2. And square root of 8, we found that to be 2 rad 2. So let's just erase all this work. And when we have to simplify this, you guys, they all have the same root and radicand, so we can combine all of them. So 20 minus 6 is 14. 14 plus 2 is 16. So 16 radical 2. It's a nice problem. Okay, 36. Okay, radical 64. That's going to be, well, be 8 right there. So 8 and 8. Well, let's just start with this. Now, you guys can break it down all the way, but I know that radical 64, the square root of 64, you guys, is 8. 8 times 8 is 64. So I know this is going to be 8 times 8, and I know that's going to be 64. Now, negative radical 96, right? Well, 4 and 24. 4 and 6, 2 and 2, 3 and 2. Well, found a pair there, found a pair there. So I know this is going to be negative. Okay, a 2 pops out, right? And another 2 pops out because of both pairs, right? And the leftovers are the 3 and the 2, right? That one and that one. Those are the leftovers. They couldn't find pairs. Simplification of that is negative 4 radical 6. So we are going to have 8 radical 64, which was 64. And then this negative radical 96, we found that to be negative 4 radical 6. And that should be your guys' final answer. All right, 38. Let's do rad 60. 10 and 6. 5 and 2. 2 and 3. There's a pair. So that pair comes on the outside of the radical. Square root of the leftovers, 3, 8, and 5, right? 2 radical 15. So that's the simplified radical of 60. Now let's look at 135. 5. Oh, what is that? 2, 27. 3 and 9. 3 and 3. There's a pair. So that pair of 3's comes out. Leftovers are the 3 and the 5, which is 3 radical 15. So we basically have 2 radical 15 from radical 60, and the 135 is basically 3 radical 15. I'm gonna erase all this stuff. Put this over here. And 2 minus 3, because, right, both of these have the same root and radicand, which means we can combine. So 2 minus 3 is going to be negative radical 15. Oh, didn't box this one. Okay. And the last one, you guys, number 40. Okay, so 7 radical 108. That's 12 and 9. 3 and 4. 2 and 2. 3, 3. Got a pair. Got a pair. So that means on the outside with the 7, because, right, we started off with 7. 7 times 2, and then times 3. Radical leftover, that one, 3. 7 times 2 times 3 is 42, radical 3. So that's that one, you guys. Okay, so now we got negative 6 radical. Well, I don't need to bring the negative, I don't think. Okay, 6 radical 180. 180 is 9 and 20. 3 and 3. 4 and 5. 2 and 2. Pair and a pair. So along with the 6, right? The 6 was already there. We have a 3. We found a pair. And the 2, we found a pair. Radical, leftover, 5. 3 times 2, 6 times 3 times 2 is 36, radical 5. Which is that. So basically, you guys, the 7 radical 108, we found that to be 42 rad 3. And the 6 radical 180, we simplified that and we found that to be 36 radical 5. Radical 3 and radical 5, you guys, they don't have the same radicand, so you can't combine them, so that is our answer. So let me just erase all this. And basically, that is the answer. All right. All right, 41. Now we're off to our multiplication. So if they have the same root, you can multiply the outside of the radicals and you can multiply the inside of the radicals. So for this one, they both have square root. So we're going to get radical 15 times 5 is 75. 25 and 3, 5 and 5. Found a pair. So that means the pair comes on the outside of the radical and on the inside is the leftover. So it's going to be 5 radical 3. Okay. For this one, they both have square root, so I'll multiply them together. Radical 140. Simplify that. 14 and 10. 7 and 2. 2 and 5. Found a pair. So that means we're going to get 2 radical on the leftovers is 7 and 5, which is 2 radical 35. All right, 43. Both of them are cube root, no problem. So that means let's multiply them. Cube root of 8. And you guys, cube root of 8 is 2. 2 times 2 times 2, 8. All right, so 44. Now, for this one, you guys, this is only with square roots, okay? Let's do square root of 2 times square root of 2. That's the square root of 4, but that's 2. If we did square root of 3 times square root of 3, that's square root of 9, which is 3. So do you guys notice if you multiply a square root to itself, you get the number inside the root to be your answer. See? Radical 2 times radical 2, 2. So basically, if you square root and times it by itself, you're going to get the number on the inside of the radical. So when you guys take a look at this one, radical 18a cubed times radical 18a cubed is basically 18a cubed. Nice simple trick for you guys, okay? 45. Oh, look at this one. Radical 75x to the 7th times radical 75x to the 7th is 75x to the 7. Okay, square root times itself, you're going to get the inside of the square root back. Okay, all right, 46. They both have the same root, so we can multiply the insides. Cube root of 2 times 5, 10. And a squared times a to the 3rd. Now, the 10, you guys, I know that's going to be 2 and 5, but there's no way that's going to have a group of 3 of any type, so can't do anything with the cube root of 10. But for the a cubed, right, they take this power, right? So 3 divided by the root, which is 3. So 3 divided by 3 is 1. That means 1a gets to come on the outside, and the leftover is cube root of 10. Okay. All right, 47. Both of these are square roots. So square root of 15 times 3, 45. X to the 5th times x squared, x to the 7th. 9 and 3. Oh, no. 5. 3 and 3. We found a pair, right? So on the outside, we are going to have 3 square root 5. And now let's look at your variable. Has a power of 7, and the root is 2, right? If it's blank, that means it's 2. So 2 goes into 7 how many times? 3. So 3 x's get to come on the outside, and there's 1 left over. That means the x leftover will go on the inside. So 3x cubed radical 5x. Okay, 48. Both of them are square roots, so we can multiply square root of 15 times 5, which is 75, a to the 10th. So we get 25 times 3, 5 and 5. 5 and 5 is a pair, so we're going to get 5 square root of 3. Now let's do the variable, right? 10 divided, and the root is 2. So 10 divided by 2 is 5. That means 5 a's come on the outside. No leftover. So that's your guys' answer. 5a to the 5th, radical 3. Okay. All right, 49. Both of them are cube root, so we can combine or multiply. Cube root of s squared times s to the 4th is s to the 6th. T to the 4th times t to the 6th is t to the 10th. Now take each variable and its exponent and divide it by the root, which is 3, right? So 6 divided by 3, which means 3 goes into 6 twice. That means we're going to have 2s to the 2nd. No leftovers. Now let's do t to the 10th, right? 3 goes into 10 3 times. So we're going to have 3 t's on the outside, and there's 1 remaining t on the inside. So I'm just going to put this over there so you guys can see. Cube root of t. And this is your guys' answer. Okay. We got 50. All right, cube root. Both of them are cube root, so we're gonna have cube root. Now multiply them, right? Okay, x plus 5 to the 2nd times x plus 5 to the 4th, which is x plus 5 to the 6th. Now, the 6th power, divide that by the root, right? So 6 divided by 3, which is 2. That means on the outside, we're going to have x plus 5, and there's 2 of them to the second. No remainder. So it's x plus 5 to the 2nd power. All right, so 51 and 52, you guys, that's kind of like the challenge ones, right? So, okay, notice both of these do not have the same root. So let's make them into exponents. A to the 1/2 times a to the 3/4. Remember, the root is the denominator, right? Now, since they both have the same base and you're multiplying, that means you have to add your exponents together. I'm going to make this. Okay, now you gotta get a common denominator, right? So we're gonna have a to, let's multiply this by 2, multiply by 2, so we're gonna get a to the 2/4 plus 3/4. That's gonna equal a to the 5/4. Now 4 goes into 5 one time, so that means we're gonna have 1a on the outside, and we're gonna have the 4th root of a. Right? 4 goes into 5 one time, and there's going to be a remainder. So the remainder is 1a, 4th. And that should be your guys' answer. Little tricky. Okay, here's the juggernaut. So this is they don't have the same root, so we can't multiply them together, right? So let's get them into exponents. X, y to the 3rd to the 1/2 power times x squared y to the 1/3 power. So let's distribute this 1/2 and multiply it to each power on the inside. We are going to get x to the 1/2, y to the 3/2 times x to the 2/3, y to the 1/3. So this base and that base are the same, and this one and this one are the same. So we're gonna have x to the 1/2 plus 2/3 times y to the 3/2 plus 1/3 equals, so now we gotta get a common denominator, right? So for this one, we're going to multiply top and bottom by 3. And for this one, we're going to multiply top and bottom by 2. For this one, top and bottom by 3, top and bottom by 2. So we're going to get x to the 3/6 plus 4/6 times y to the 9/6 plus 2/6. So we're going to get x to the 7/6, y to the 11/6. So 6 goes into 7 one time, so we're going to get 1x on the outside, 6th root of x, because there's 1 left over, and we're going to get 6 goes to 11 one time, so 1y on the outside, and then 6th root, 5 leftovers. And then notice, you guys, this and this have the same root, so you can multiply those together. So we're going to get x times y, 6th root of xy to the 5th as the final answer. Ooh. Good amount of work. That's why these ones, you guys, are the more of the challenge type problems, okay? hopefully you guys, that helps you guys out, and just keep on working on it, okay?